Welcome to Shift, a college admissions ACT, SAT, and CLT podcast for a changing world. I'm Tyler, the founder of Achievable, and we have an affordable ACT course that includes everything you need to ace the test. A full textbook, tons of ACT questions backed by a memory-enhancing algorithm, videos on key topics, a built-in study planner, and full-length practice exams. You can get a free trial by going to achievable.me, and if you like it, the code podcast will get you 10% off at checkout. Now, let's get started. So today we've got Clay Daniel from Clayborne Education with us. And Clay, I'd love if you could just introduce yourself briefly.
Happy to. Thanks for another fun conversation about standardized tests, Tyler. I consider myself a test nerd, I guess you could say. I love to talk about the content. I've been in test prep for about 20 years in a number of different ways. And I guess 15 years ago now started my company, Clayborne Education. We do all sorts of tutoring and test prep. And our subject today is a particular fondness to me, the newest kid on the block, so to speak, the classic learning test. So I really like talking about its content in particular.
Yeah, and I think this will be a good demonstration of how it's different, right? I think that a lot of these questions that you've got picked out here are noticeably different in their approach than the SAT.
Yes.
Yeah, so I'd love if why don't we start with kind of the first one on your list here, if you don't mind reading the question out and the answer choices, and then we can kind of talk through it.
Sure. Yeah. I'll do that. And then if I could give an introduction to this type of question once everybody has a chance to kind of hear and digest this. But it says this:
Hmm.
how many integers between 1 and 50 inclusive meet both of the following conditions given in the statements below? And the statements are: the number is prime and the number is odd. And we have a
Hmm.
number of different choices: 1, 7, 14, and 15. So kind of a range there.
Hmm.
But a word of introduction before I'd love to hear your thoughts on this question and how you would approach it and to walk through it. But two conditions questions, as these are something I've never seen. I've never seen the like of this exactly on another standardized test. I think it's unique to the CLT. It's something that they've kind of created and that consistently shows up on their quantitative section. But this idea of doing math reasoning in a way that involves this numerical reasoning, but also the logic of trying to meet these conditions and figuring out what numbers, maybe certain numbers meet only one of the conditions but not both, and then they have these different characteristics. So I think they're particularly interesting questions and very different from most standardized test questions.
Yeah, no, I think it's really interesting, and it's going to force you to understand some key math rules, right? I mean, you need to know how prime numbers work, but it's also, this would be a case where like knowing what all the prime numbers are would be probably where I would start. And so, yeah, it's forcing you to kind of memorize something different than maybe the other tests do. Yeah, this is an interesting one because realistically, um, I think I would probably literally just like write out all of the prime numbers in a row. Which begs the question, is one a prime number? That's something I actually forget.
One is not technically considered a prime, and the best explanation I've encountered for that is that you may recall doing the process in math of the factor tree at some point in your math education. uh, you know
Right.
the point is to break down a number into its prime factors. So like 24 is 2 times 2 times 2 times 3. But
Hmm.
if we considered one prime, we would have this infinite sequence where we could say 1 and 24 and then break down 24 into 1 and 24 and then over and over and over again,
Right.
and it would never end. Nobody wants that.
Yeah. Yeah, no, that makes sense. So yeah, I mean, I don't know all of and then, the other question is two a prime number? That's another interesting one.
Yeah. And what do you, I mean, if the definition of a prime number is,
Oh, I guess it doesn't matter because it says is a prime number and is odd, so we can just skip that.
We can, although it's
Um,
important to note that 2 is the only even prime. So it's the only one we're going to have to knock out.
mhm. Yeah, because every other prime can be divided by two, naturally. Every other even number can be divided by two. Yeah, so I don't. I guess I would start there. I would try to list all the prime numbers out, and then you add them up. So it's really just about knowing the properties of prime numbers. And I mean, if even if you don't have it memorized, you can do it yourself. So, 3, 5, 7, those are all prime.
Right.
9 is not. 11 is, so 11. We could do, I don't know, do we want to go through all of this together, or do you just want to tell me the answer?
Well, let's think about it. Whenever you're doing a standardized test question, of course, the clock is ticking. So let's think if we can streamline the process by thinking of some general principles. Like if you're looking at
Mhm.
odd numbers, can you tell me a digit that a number is going to end in that you know it's not prime as long as it's a two-digit number?
Yeah, 5 is a good one.
Yeah, so let's
Yeah.
skip the fives first off, except for, of course, the number 5 itself, as you already
Hmm.
said. And then the next thing you would probably knock out are the multiples of 3. And there's a nice handy
Hmm.
trick for that. You remember the adding the digits trick? Did you ever
Yeah,
learn
well, that's for 9, right? Where it's like,
9 or 3?
3. Yeah, exactly. So I remember it for nines, but not for threes.
Yeah, it works for threes as well. So when you jump up and you're getting a little higher and maybe you don't right off the top of your head know if a number is divisible by 3, like take 39 for example. If once we get that high,
Hmm.
that helps to say, oh, 3 plus 9 is 12. The digits of 39 add up to a multiple of 3. So 39 must itself be divisible by 3. So really, if you apply, I think those two elimination rules, no fives, no two-digit
Hmm.
numbers with 5, knock out the odd numbers that are multiples of 3, it makes the process a little quicker. And then finally, let's just think of it in terms of like decades, groups of 10. Um, you had 3
Hmm.
odd primes in the first 10.
Yep.
How many primes are there in the second 10, between 10 and 20?
Uh, it'd be 11, 13, 17, 19.
Correct. And what you'll find if you keep going up by like decades is that most of those decades only have 3 prime numbers. It's actually somewhat rare to have 4 like that
Hmm.
one. Um, but we're at 7 so far, and we still have 3 decades to go. So I'll ask you, can you narrow it down to a couple of answers?
Yeah, well, in the answer 1 and 7, those are clearly wrong. So it has to be either 14 or 15 different numbers.
Right. Yeah. So to give a
Integers.
integers, right? It has to be C or D. And if you were doing the CLT and you were worried about your time at this point, you could definitely make a 50-50 guess, having thought through it to this point. That would be
Hmm.
valuable. Um, as it turns out, the 20s are kind of opposite of the teens. They go the other direction and only have 2 prime numbers, 23 and 29. Um, and then
Hmm.
30 does the same thing, 31 and 37. So once
Hmm.
we've kind of, if you think about the groups of 10 as averaging 3 prime numbers apiece, we've jumped above that average with the teens, but now we're back below that average. And it does end up being 14.
Hmm.
Although, interestingly, it's only because of one last elimination. When we hit the number 49, how do we know if that's prime or not?
Well, I know it isn't because it's 7 times 7. It's my multiplication table, yeah.
And that's one last interesting thing about this problem is that that's the only odd number between 1 and 50 that doesn't get eliminated by our other tests. It has to be divisible by 7 is the test there, but it's kind of unique among numbers less than 50. It's the only composite number that's odd that we haven't already eliminated with like 3 or 5, if that makes sense.
Hmm. Yeah, very interesting. All right. Yeah, we got that one right.
Yeah, if I didn't make it
Hmm.
clear, 14 is what, spoiler alert, that's what you get.
Yeah.
I think we can probably leave it there without going further. Sound good?
Hmm. Yeah, perfect. Yeah, let's move on to the next problem.
Great. So for number 5 here, it's the same category, and I did want listeners to hear one other because this question type is so unique. So would you mind reading that one out?
Yeah, sure. So it says, how many integers between 100 and 500 inclusive meet both of the following conditions given the statement below? And the conditions are the number is a perfect square, the product of the number's digits is not zero. Interesting. So this is another conditions question.
Mm-hmm. And one thing we didn't.
And number is a perfect square. That means what? Like 2 times 2 is 4, 3 times 3 is 9, kind of thing.
Yep. And a good principle as these start to get harder is to think about which of these conditions feels more accessible to you to make an initial list, because we want to probably list all the candidates for one of the conditions, and then we can go in and cross out the ones that don't meet the other condition.
I feel like it would be easiest to do perfect squares first.
Probably right.
Yeah. So yeah, what are they? It's like, so it's between 100 and 500. So, you got,
Inclusive. What? Let me just add that word. What does that mean?
oh, that includes 100 and 500. That's clever. Yeah, so I mean, 100 is 10 times 10.
There we go. That's our
And you
first
just
one.
kind of go down, you just go up the list, right? So 11 times 11 is 121. 12 times 12 is, I think, 144.
Mm-hmm.
Yep. 13 by 13 is 169, which I remember for some reason.
Okay.
Uh, now I'm going to start using a calculator, but you get the idea. You start listing out all of these
Well, I'm glad you mentioned
perfect squares.
a calculator because people hearing this problem are probably have the same instinct, but you actually can't use a calculator on the CLT.
Okay.
So that makes this.
So you got to know your
You
multiplication
really
tables.
do, yeah. We for purposes of this exercise, we could use a calculator, but um, I think it's a lot more interesting to think strategically about this and try to put ourselves in the testing format where maybe we're not super confident that we can continue listing the perfect squares all the way up to
Right.
500. Tell you what, so let's just take a snapshot of what you have so far: 100,
Mhm.
121, 144, 169, and evaluate them with the second condition. Talk about that one.
Right. Well, so the product of the numbers digits is not zero. Product meaning you multiply the digits together, all of them. And so what that really means is just if there's a zero digit or not.
Exactly. So which of our
Yeah,
choices is
so
out?
100.
Okay. And the others are
And
fine?
then I believe so, yeah.
Yeah, we're looking good with the other three, which is helpful because we already have three examples. Once again, we're down to two options when we look at the
Mhm.
multiple choice.
Yeah, sorry, I don't know if I read the answer choices. The answer choices are zero integers, two integers, nine integers, and 11 integers. So we already have narrowed it down to C and D.
Good. Now let's think about another shortcut here. So maybe we don't have to list them all. We could think
Mhm.
about, instead of trying to list them all, we could say, well, what's the highest one just less than 500? Now I bet you can tell me what 20 squared is.
400.
400. That's a nice round number. The next two are kind of difficult, but it turns out that 22 squared is the largest one we're going to consider because that's 484. And after
Hmm.
that, we jump over 500.
Okay.
So if I think about the number we started with, not the 100, but the square root of that, what did we start with to square it?
Um, 10.
We
Yeah.
started with 10 and we went through 22. If we count inclusively numbers on both ends, how many numbers is that from 10 to 22?
12? No. It'd be 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Oh, it is 12. No, it's 13. Sorry.
13. And the rule
13.
for
Yeah.
inclusive counting is, yeah, you have to add one if it's inclusive counting.
Hmm.
So we know it's 13.
Yeah, so it's,
Go ahead.
and we know that two of them have zeros in the number itself, right? Because if it doesn't have, if it's not 10 or 20, then it's not gonna multiply out to the product of the numbers digits being zero. So then you could say it's 13 minus 2.
Nailed it.
All right. So the answer is 11. Yeah, that's a little bit easier than listing them all.
Yes.
It also, though, that I think that's a good example, right? Because it shows sort of, I think tests like to do this. And I mean, it's something that I even struggled with on the GMAT because there will be sort of a pretty obvious, straightforward way to do something, but it'll just take way too long. And the question is designed to be solved a different way that kind of goes around the brute force way. And I feel like this is a very similar instance of that.
Yeah. Excellent.
Yeah, cool. I'm ready for the next question.
Great. So having seen that unique question, let's look at it. I think similarly, in some ways, similarly unique in the sense that it still uses a lot of logic. You're going to see that theme running through all the questions today, and the emphasis in the CLT quantitative reasoning on logic. But number 9, I'll go ahead and read that one. It's quite lengthy, a lot to consider. A student is reading the Iliad and Out of the Silent Planet as a summer assignment. She reads 12% of the Iliad and 48% of Out of the Silent Planet in June. In both of the next 2 months, she reads more than double the percentage of the Iliad as she does in Out of the Silent Planet. Which of the following must be true? So we now have to evaluate 3 possible statements. Number 1, the student does not finish the Iliad. Number 2,
Mhm.
the student does not finish Out of the Silent Planet. And number 3, the student ends up completing more of the Iliad than she completes of Out of the Silent Planet. And maybe we can read the choices later because they're all just some combination or none of the above.
Yeah, of those three options, one, two, and three.
Yeah, so any thoughts about where you might begin here?
Yeah, so clearly the key crux, or at least to me, like I think the key crux of this is the fact that she has read Out of the Silent Planet and she's read 48% of it, which is slightly less than half,
Okay,
right? So that's the first thing that I noticed.
good. Yep.
And 12% is also, if you multiplied it by 4, you would be at 48%. If you multiplied it by 8, you would be at, 96%. So in either case, so just like for me, I'm trying to like when it says this, the options are the student does not finish the Iliad or the student does not finish Out of the Silent Planet. The first two things I go to are like, okay, well, let's figure out like the logic structure of this problem, and then we can usually tell which of those things is true. I feel like one of those things is guaranteed to be not true in some way.
Okay.
Um, so okay, she reads double as much of Out of the Iliad as she has of Out of the Silent Planet. The most that she can read of Out of the Silent Planet is 52%. If she reads 52% of Out of the Silent Planet, she'll have read 104% of the Iliad, or a total of 116. So that's not possible.
Right.
So I can, I think we can say that, you know, so if, yeah, so I think then number two, answer number two, the student does not finish Out of the Silent Planet, is probably true. But let's
Yes.
keep going.
Okay. Yeah. Good
Um,
thinking.
yeah, so then the second thing is the student does not finish the Iliad. So if she has read 12% of the Iliad, that means she has 88% left. 88% divided. by 2 is 44. She could read 88% of the Iliad and finish it and still satisfy the requirement that the student does not finish Out of the Silent Planet. So
Excellent.
we don't know whether the student finishes the Iliad or not.
Good.
Yeah, so the third one is the student ends up completing more of the Iliad than she does Out of the Silent Planet. I think that one is pretty easy to knock off because if she just reads 2% of the Iliad and 1% of it Out of the Silent Planet, then that breaks that one.
Yeah, maybe she really
Um,
runs out of steam there and gets tired of these books.
yeah, it just doesn't read either of them, basically. Um, so therefore, the only thing that must be true is that the student does not finish Out of the Silent Planet, which is answer choice A.
Answer choice A says two only. Then we've got one and two only, two and three only, or none of the above must be true. So interestingly, once you figured out that Roman numeral two was true, that only ruled out choice D, none of the above, right?
Yep.
So you really did have to think about the others. And you were correct, despite one small oversight. You were, I
Mm.
think you overlooked the phrase more than before double.
Oh, more than double. Oh, okay.
It worked out because still, what it would have taken to finish the Iliad required that she couldn't finish Out of the Silent Planet. But it actually makes it even more true, or I guess, yeah, more true that we don't know statements one and three because she could finish the Iliad with 88% and only read 1% or 0% of Out of the Silent Planet.
Oh, okay. Yeah. No, I mean, I was just thinking it was a 2-to-1 ratio, and I got lucky that they didn't burn me on that.
Yeah, I mean, that's really easy to do when there's just so many words. That's,
Mhm.
and you add in the element, the CLT has some challenges to it. It's a digital test, it's on computer, it's not on
Mhm.
paper. We'd already talked about the calculator thing. So, absent the ability to underline or circle things, I really try to train my students in using their scratch paper, even to write down
Mhm.
phrases like more than double. Really,
Mhm.
yeah, it feels like tedious or it feels like that might waste time, but in the long run, that'll save you time because it'll save you from some oversights that are really possible.
Right. No, I think that's great. And I liked the question in general because it was, basically a logic question with some math in it.
Yeah, yeah, for sure.
Interesting. Yeah, so do you have any other ones that you wanted to share?
Yeah, I think there's a couple others that I think are especially again noteworthy or maybe characteristic of the CLT. Number four is a good next one. Now, this one may remind students a little more of some of the other tests. Maybe not so much the SAT, but definitely you could see this on the ACT. It's still kind of CLT like in the sense that it's asking which of the following is false. So it adds that extra sense of logic to play in because you have to consider could be true, must be false. There's a lot of that going on. So, with that preview, could you read number four?
Yeah, so it's if A and B are integers and AB equals 0, which of the following is false? That's interesting. Um, and so the answer choices are A plus B equals 0, A minus B equals 0, both A and B are equal to 0, and neither A nor B is equal to 0. Uh, huh. Yeah, so if A and B are integers and AB equals 0, which is A times B, the first thing I want to do is look at C and D. I feel like A and B and C and D are very different type. Like A and B, if that's the correct answer, it means that there's some specific combination that they're looking for. But if I think C and D are more likely. So I think that, if neither A nor B are equal to 0, then there's no way that AB can be equal 0. So D is out. And then, C, both A and, or wait, oh, so it says, wait, so which of the following is false? I want to make sure I'm answering the correct question.
Yep.
Um, yeah, so neither A nor B is equal to zero. Is that is that the correct answer? Because it says which of the following is false, and that's the thing that's wrong? Or am I
Now that's the thing
eh,
that's false. Yeah.
all right. Yeah, because I was looking at everything else and I was like, both A and B are equal to zero. I mean, that could be true, but it could also be false. You only need one of the integers to be equal to zero.
There you go. Yeah.
And then, yeah, the A plus B and the A minus B, just it didn't feel like that was going to lead to the right answer when you're talking about like products.
Products, right? Because those are adding and subtracting, and if you had any doubt, you could just plug in numbers and see the different ways that A plus B could equal zero, A minus B. Like that doesn't have to be true. I think I'm glad you mentioned
Hmm.
what you did about C. That's probably the most tempting wrong answer, um, because students might be thinking, okay, so if A times B is equal to zero, don't I need them both to equal zero? But well, actually, that would just make C true anyway. So that still wouldn't be the answer, right? Because it would be a true statement. Um, but you mentioned an important property. The zero product property just means that one of them has to be zero,
Hmm.
and and so really thinking with that number sense as you did is important, and that can also be kind of supported by plugging in numbers. So I think students should keep
Hmm.
that in mind as well. Think generally, what do I know about positives, negatives, odds, evens, zero, things like that. But if you get stuck, you can plug in some examples to confirm.
Hmm. Yeah, very cool. That was a good one.
Yeah.
And then do you want to do one more
Let's do
here?
one more. Sure. I really like number 8. And this one is trickier, probably requires some writing out, and especially without a calculator. You'll probably find it a lot harder without a calculator than with. So I'll read
Hmm.
this one. That Charles is eating a supply of his favorite candy, but very thoughtfully so. He eats 20% of the candy on his first day of delightful partaking. He then decides that he will eat only 70% as much candy each subsequent day as he did the day before. On which day of the process will Charles first have eaten more than half of the candy? And the answers
Hmm.
are just third, fourth, fifth, or sixth day.
Yeah. Yeah, so this one to me seems pretty straightforward.
Okay.
I feel like the hard part of it is like figuring out what it actually means.
Yeah.
But my interpretation of what it means is basically day one equals 20%. And then what you do is, uh, and basically you're multiplying that 20% by zero point 0.7
Mm-hmm.
each day. So the second day would be 14%, right? You
Mm-hmm.
can basically you can just do, point 0.7 times 10 is 7, and then multiply by 2.
Okay.
That's how I do a lot of my math.
Yep.
So it's, 14% on the second day. Now we're at 34% total. And then what is, zero point 0.7 of 14? Do I know that exactly? Not really, but can I guess? Well, yeah, probably. I mean, um, zero
Mm-hmm.
point 0.7 of 10 is 7, and then zero point 0.7 of 4 is kind of like 3. It's close enough.
Yep.
So you could say, you know, uh, 7 for the next day, and that gets you to 41%.
Hang on. I think
Uh,
you
oh,
forgot to add the 3
well,
to 7.
excuse me. Sorry, 10 for the second day. No, you're totally right. It's 14, then 10, which gets you to 44, and then it would be 7 the next day, which then gets you to 51. Um,
Okay.
and so, yeah, that would be, so it's 20, 14, 10, 7. So that's 4 days. So it would be on the fifth or on the fourth day,
Very good.
you'll be at 51%. Yeah, the wording is really specific,
Uh huh.
and you got to pay a lot of attention to it.
Great. And I think that may have made sense for those just listening to it, but it really underscores the importance of mapping that out. Like I really think you need to write day
Hmm.
1, 2, 3, 4, put your individual
Yep.
numbers under each day, and then have a cumulative running count of how it's going as you did, after day 2, what is it? After day 3, is it? But be careful not to be multiplying the 75% by the total you have before, but only by just the previous day.
Hmm.
And then,
Yeah, makes a ton of sense.
and I think the other slightly tricky thing, I mean, your answer was right, but it's a little bit fortunate that 7 times or 0.7 times 14 is so close to 10. It's 9.8.
Right.
So when you rounded it up to 10 and said, then you got to 51 on the fourth day, it turns out
Hmm.
that's like something like 50.85 or something instead. But the rounding was close enough that you still crossed that 50 threshold. You just got to be
Right.
careful. That had been like 9.5 or something, and you rounded it to 10 and then kept using it. You might have thought you crossed 50 when actually you hadn't because you rounded too much.
Right. Yeah, you gotta be careful. So how would you, without rounding, what would you do instead?
Well, I really like the rounding. I think you did it just the right way when you thought, let's call it 10, but you might just make a separate note to say, okay, zero point 0.7 times 14 is actually 9.8, but I'm going to call it 10. Maybe just make a separate note that I lost zero point 0.2 in that process. I'm actually like zero point 0.2
Right.
further along than I should be. And so then when you say, well, the next step is I'm going to do, you did zero point 0.7 times 10. Well, if it's really zero point 0.7 times 9.8, all you're losing is zero point 0.7 times zero point 0.2 in that
Hmm.
next multiplication. You're only losing an additional 0.14, which isn't enough to mess up the process. But keeping a running tally of what you lost by rounding, or at least if you're not going to be precise about it, at least have a general idea. So you can say, oh, when I get to 51, I can be really confident. I didn't lose an entire whole number one. I just lost little fractions here and there.
Right. Yeah, that makes sense. And I think it's also like super important for just like there I was lucky in that the total number did not go below 50, right? And that it like, it wasn't on the fourth day like 49.8 and then the
True.
fifth day it goes over.
Right.
I think it's just like, you know, taking shortcuts is fine, but just like having a sense of like how big it is.
Yeah. Yeah. What, how much did I just round? And just be careful with that. It's an excellent strategy with those guardrails in place.
Yeah. Okay. Yeah, then that all sounds good. Well, thank you for sharing these questions with us. I feel like I have a much better understanding of like the type of questions on the test. And yeah, like again, really reminds me of the GMAT in a lot of ways. It's very logic focused,
Yeah.
and it's a lot more about the thinking behind the math than like memorizing the math.
That's right. And that kind of ties into just students thinking about which test to take. Like if the CLT is a real candidate, that's something that they can consider. How much does that kind of thinking appeal to them? Because I think these questions are really fun, but if you'd rather do textbook method of linear equations and you'd rather just do y equals mx plus b repeatedly, and just kind of work that out, and you're more comfortable with that, maybe the CLT isn't as great a test or as great a fit. It's nice to have options.
Yeah, it's nice to have options, and also I think I mean, I personally would prefer if, standardized testing went more in this direction in general, right? Like,
Mm-hmm.
again, less just like memorizing stuff for the sake of memorizing stuff, and a lot more focus on just broader, like, logic and critical thinking and reasoning and stuff like that.
Yeah, yeah, I think it's a great trend.
Missions podcast for a changing world, hosted by Tyler from Achievable with Clay Daniel from Clayborne Education. You can get a free trial of Achievable's ACT course by going to achievable.me and using the code podcast to get 10% off at checkout.